I'm Anil Kumar. Welcome to my series on fractions. Here we'll talk about fractions greater than 1. And this video is going to be part of our Global Math Institute collection, where we encourage young children to start early. Now let's talk first about fractions, and then we'll get into fractions greater than 1. So very familiar. If I say fractions, you think about terms like half, let's say 2 over 3, maybe 5 over 6, or something like that, correct? So what we notice here is that it is in two parts, which is numerator over denominator. Normally, you see that numerator is less than denominator, right? So normally, it is numerator is less than denominator. Now that is what we call proper fraction. So I hope that part is clear. Now what we are getting into is greater than 1. So let's see what is a proper fraction. So we have something which is whole, right? So, and let us say we take a part of it. That is to say, what we could do is that we could divide this whole into two equal parts. Let's see something like this, right? So we begin with something as a whole, and this whole is divided into equal parts. So in this case, we had one hexagon which has been divided into two trapezoids. You get the idea, right? So equal parts. Now if I take some of them out, then we get part of whole. So this is part of whole. And we write this as fraction. So what you see here is 1 out of 2, right? So earlier we had two parts. You get an idea? So now what we did was that we took away 1. So what we are left with is half. So in this case, it represents half. Correct? So that is how you get fraction of half, right? Now let's do 1/3. So I could again take one hexagon, divide it into 3 equal parts. Do you see that? Now if I take away 1, what am I left with? I'm left with 2 over 3. This is what I'm left with. 2 out of 3. So we had a whole divided into 3 equal parts, and now we are left with 2 out of 3. Correct? To make it 5 out of 6, we will again take a hexagon. Hexagon is a very nice figure to work with. And we could divide this into 6 equal parts. Correct? As you can see, there are these 6 equal parts, right? So we are dividing it into 6 equal parts. So a whole has been divided equally, that is very important, into 6 equal parts. And if I remove 1, what am I left with? I'm left with 5 out of 6. So this is what is 5 out of 6. Is that clear? So these are the cases which we saw so far. So we know fraction is kind of less than 1 part of the whole. But think about this. We have this whole and we have something more. For example, we could have 2 pieces and we have something more. Now, what you notice is we have 6 triangles here and 3 here, 9 triangles. Now that becomes greater than 1. Do you see we have more than one? This is one whole and this is part of another whole. So when that is the situation, we call it fractions greater than 1. So now you see how we get fractions greater. Okay. So fractions greater than 1. Okay. So that is the whole concept. So now we get something which is 1.5. What we get here is 1 plus half. So that is definitely greater than 1. So that is our main topic today. We'll talk about fractions greater than 1, as you can see here. And we'll see how to represent them. They could be represented as mixed numbers or improper fractions. And then we'll work with them. So I hope the concept is clear to you. So let's move on and explore fractions greater than 1. Now let's try to understand what are mixed numbers. We'll begin by taking an example. Well, these are whole numbers. Like this is 1 is a whole number, correct? And if I add something which is a fraction, for example, half to it, then I get 1.5. So we write this as 1.5. Now that becomes a mixed number. So what you notice here is that part of the number is a whole number. So this is a whole number. And the other part here is a fraction. And you also see it is more than 1, correct? So one whole and something more, right? So more than 1. So we're talking about something which is more than 1 or greater than 1. So it is more than 1. Correct? So that is what we'll try to understand. You could see it like this. Now let's get back to our blocks. So we have these two hexagons, right? Now how many do we have? 2 of them, right? Definitely these two are more than 1. Now let's divide them into equal parts. Let's say like this. All right, so again we still have 2 of them. Divide it equally into 2 equal parts, correct? Now if I take away one of these parts, what am I left with? This is 1.5. You get an idea, right? So we get 1 whole and half of it. So that is what we are trying to show you here. So we have 1 whole and half of it. That is 1.5. So I hope you got the idea. So that is how you represent something which is greater than 1. And we call them as mixed numbers since it has a number, a whole number, and a fraction attached to it. So you got the concept, correct? Let's take more examples now. Now this time, let me divide our hexagon into 3 equal parts, right? So in that case, what are we looking into? 1/3, correct? So let me do it like this. So we have 1 whole divided into 3 equal parts. Let me have another one also divided into 3 equal parts. Now if I take away 1, what am I left with? Clearly, it is 1 whole and then 2 out of 3. The third one is missing, right? So 1 whole, 2 out of 3. So if I write 1 whole, 2 out of 3, I hope you understand. It is 1 whole divided into 3 equal parts. The second one also divided into 3 equal parts, but we have only 2 of them left. So that is what it is. Correct? Can you do the same for, let's say, 1/6? Okay, so we can take a hexagon divided into 6 equal parts, right? So there is 1. So we are dividing it into 6 equal parts. Now, so that is 1 whole, but now let's add something to it. So let's add something to it. So what I'm doing here is adding something more on it. So in this figure, you notice that I have only 5, not the sixth one. Sixth one is missing for me. Correct? The sixth one is missing. So what we can write this as, the missing part is 1 out of this 6, but in all we have 1 whole and 1, 2, 3, 4, 5. 5/6. It's a very useful concept. So I hope you got the whole concept here, right? So that is how you represent mixed numbers. So let's take few more examples. For example, I could take this piece and divide it into 2 equal parts. Do you see that? And I take one more, again divide it into 2 equal parts. However, I give one part to somebody else, so what am I left with? 1.5. Correct? I'm left with 1.5. So I hope you get this concept of mixed numbers. So mixed numbers are greater than 1. They have a whole part and a fraction part, right? So that is how we represent a mixed number. Now as a practice, I would like you to write these as mixed numbers. Let us say we have only a part of this, right? So we have whole of this. So let's make it whole. And I want to actually show this number here, 1. Let's say 1 out of 6. How can I do it? To represent 1 out of 6, I have to have one complete whole, right? So this is one complete whole. And in the other, I need only one piece. Rest removed. So that gives me 1 out of 6. Correct? Now, for you, you can practice at home. Now, let's do 2 1 out of 3. So how could I do 2 1 out of 3? So using these blocks, I could actually take 3 of these. Now I know 2 1 out of 3 is more than 2 but less than 3. Correct? It is less than 3. So what I could do here is that divide one of them into 3 equal parts. Correct? So I could divide one of them into 3 equal parts. And I say, well, these are whole, right? So if you want, I can place these triangles, but from now onwards, we'll not show the division of the whole, right? We'll show them as unit in itself, one whole piece, correct? We'll show it as one whole piece. So this time I'm making one for you. Okay, it's fun learning like this. I hope you are enjoying. So well, we have these 2 full, and from the third one I take away 2. So what do I get? I get 2 holes, right? These holes have been shown to be divided into 3 equal parts, and the last one I have just 1 out of 3. Correct? So this is what I say is 2 1 over 3. Now in the next part, I will show you how to write these mixed numbers as improper fractions. So the idea here is these are each 1/3, right? So how many 1/3s we have? We'll answer this question. How many 1/3s? So in this case, 1, 2, 3, 4, 5, 6, and 1, 7. So what we have here is 7 1/3. So we could write this as 7 over 3. Do you see that? So when I write this as 7 over 3, it becomes improper fraction, which we are going to explore further. So I hope you understand the concept. So that is how the mixed number is linked with the improper fraction, right? So here we have something which is 2 whole 1 out of 3, but we can also write this as 7 1/3. 1, 2, 3, 4, 5, 6 and 1, 7. 7/3. Does make sense. Let's move on and understand improper fractions now. Now let's again start with 3 pieces, right? So we have 3 wholes, right? So we have 3 wholes, whole numbers we can say. And what we do is we divide them into 3 equal parts, right? So each is divided into 3 equal parts. Correct? Each is divided into 3 equal parts. Now, let's remove some of it. So we have made less than 3, correct? How much is this? Now you learned earlier that I could always write this as 2 wholes, and since we had 1/3, it is 1/3 left, so 2 1/3. That is what we call this as mixed number. Now, how do I write it as only a fraction? Well, as you can see, we have 1, 2, 3, 4, 5, 6 and 1, 7 1/3. So I could write this as 7 out of 3, correct? 1, 2, 3, 4, 5, 6 and 1, 7. 7/3. So that is what we call improper fraction. This is what we call improper fraction. Now, why is it improper? Well, clearly here, what we have is that numerator, which is that top part, is greater than denominator. Therefore, it is improper fraction. Does make sense to you? Correct? That is the link. So I hope you get the concept. Now, play with your diagrams and blocks and make some more improper fractions. Let's get back to the hexagon. We can say this is 1 whole. That means you could divide it into, let's say, 6 parts also. So I'm not dividing that one into 6 parts. However, I'm dividing this into 6 parts and removing some, right? So what I'm doing here is I divided this into 6 equal parts. So I got 1 whole now, right? And from here, I have 1 where I'm going to remove some pieces, right? So let me show it here again. So what we will do here is that we have 1 whole which has 6 parts as shown. In the other, we have just 2. So we could write this as what? We could write this as 1 whole and 2 out of 6. Each is 1/6. Did you see? Each is 1/6, 2 out of 6. So that is mixed number, and this could be written as 1, 2, 3, 4, 5, 6, 7, 8 out of 6 as improper fraction. Do you get an idea, right? So it could be written as both. So when we have improper fractions, numbers greater than 1, we could write them both as mixed number or as a improper fraction, where denominator is less than numerator or numerator is greater than denominator. So I hope this concept is clear to you, right? So let's take a few exercises. Try this out. So let's take these 2 pieces, and I can divide them into 3 equal parts. Let's say these are my 3 equal parts. I keep one as a whole, and in the other one, I have only one piece. Now, what does that represent? So it is one whole, right? And 1 out of 3. Do you see that? I could write this as improper fraction. We have 4 of these triangles, and each is 1/3. Is that correct? So that is how you can understand a link between improper fractions and mixed numbers. Correct? So I hope that helps you to understand the concept. Now, if you don't have blocks, what you could do is you can just make rectangles. So let me show you with rectangles. So we have 2 rectangles here. I'm going to represent one whole 1 out of 3. We can divide these rectangles into 3 equal parts, let's say like this. And if I have to represent one whole 1/3, then we'll color one completely. So that is one whole, and this is 1 out of 3. Does it make sense? Correct? And as such, if you count, these are 4/3, right? So you could write this as 4 out of 3 also. So that is a good way of doing it. So at home, try this exercise. Now here's a question for you. Now I have these rectangles. I'm making 3 of them this time. Okay. You need to represent 7 out of, so if I write here 3, we know it is more than 2, correct? So this time make it 7 out of 3. That means divide each into 3 equal parts and select 7, correct? So that is what you'll get. Divide them each into 3 equal parts. Imagine they are 3 equal parts. Is it okay? And color 7. So we'll color this 3, which is 6, and 1 more. Does it make sense? 7. Okay. So continue with this exercise, and now I would like you to give you a question for your homework. So let us say if I have 7 out of 4, it is equal to what as mixed numbers, and also show it in a diagram. 7 out of 4 means how many 1/4 you need? You need 7 1/4. So 4 plus 4 is 8. So that means you need 2 wholes, correct? So for this, you need 2 wholes, because 4 plus 4 will make you 8. Divide this into 4 equal parts, which I could also do like this. And then select 7. So 4, 5, 6, and 1, 7. Does it make sense? So what we got really is 1 whole and 3 out of 4. So I hope that was fun learning. Now, we see that both improper fractions and mixed numbers are related, and let's see another method of finding their relation. Now, let us learn how to convert mixed numbers into improper fractions, right? So, let me write down a mixed number here. We have 1, 2 out of 3. So that is a mixed number. You need to convert this to improper fraction. What is this equal to? So let's get back to our model. So we have 1 whole here, right? Which has been divided into 3 equal parts. Simply because 3 was in the denominator. You understand the concept? Why we divide this into 3 equal parts? Since 3 is in the denominator. Now it is 1 whole. We need 2 out of 3. So here is another similar block. And we divide that into 3 equal parts, but took only 2. You get an idea, right? So we have 1 whole, 2 out of 3. How many 1/3 do we have? 1, 2, 3, 4, 5. So we could write this as 5 1/3. Both are equal, correct? So you could do it using a model. So we did it using a model, correct? But always it is not easy to make a model, right? Let's see how to do it using simple operation. So when we say 1 whole 2 out of 3 and we divide it each in 3 equal parts, what we could do is we could multiply 1 by 3. So we do 1 times 3 and add 2. Now the parts are 1/3, so 3 remains in the denominator. 1 times 3 is 3. 3 plus 2 is 5. So we get 5 out of 3. Does it make sense to you? So that is how you could convert. Let's practice. If I have 2, 3 out of 5. Now we are getting into bigger numbers. What could I do? I have to multiply 2 times 5 and add 3. In the numerator, denominator remains as 5. We get 2 times 5 as 10 plus 3 is 13. Correct? We could even do bigger numbers. This time 5, 1 over 2. That means you multiply 5 by the denominator 2 and add 1. That goes on the top. 2, the denominator remains same. 5 times 2 is 10 plus 1 is 11 divided by 2. You get an idea. So that is how you convert from mixed numbers to improper fractions. You get an idea, correct? So here is a practice question for you. Let's do 1, 3 out of 4 equals to what? And the last one here is 2, 3 out of, let's say, 3 out of 7, okay? So try them out. So I hope that makes sense, correct? So now you learn how to convert mixed numbers into improper fractions. You could also use your model to verify, correct? So let's give a model here and do some exercise using the model. So this time what I will do is make some rectangles as we did earlier. So let's say these are rectangles of same size. We are taking 3 of them. We are dividing each into 4 equal parts and shading some of them. So we shade this completely. This also. And we shade 3 of this. You have to write this as both mixed number and improper fraction. Correct? And show conversion. I hope you understand, correct? So pause the video, answer this, and then look into my solution, correct? Mixed number, simple. 2 wholes and 1/4 how many? 3 out of 4. To get the improper fraction, count how many 1/4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of 4. And how to show the conversion? We have to do 2 times the denominator 4 plus 3 divided by same thing. You get 11 out of 4. Does make sense to you, correct? So that is how you should be doing it, correct? Now here is a test question for you. Now this time you have to divide and then figure it out. So I'm giving you the number which is 1, 3 out of 5. So first part, write this as equal to in improper fraction. And in second part, shade or color, and check your answer, whether it is right or wrong. Is it okay? So try it out. So I hope you find this exercise interesting. So let's move on and now see how to convert improper fractions to the mixed numbers. This time we have a model and we'll write what will this represent as improper fraction, right? So we see that one hexagon is divided into 6 equal parts. So we have a hexagon and we have 6 equal parts. So each is how much? So this triangle here represents what? So each is 1/6. Also written as 1/6. Correct? Now in this, how many of these triangles are there? Now in this, what we notice is that we have 7/6, right? So we have 7 out of 6 in the model. Do you see that? Now what you have to do is write this as a mixed number. Now when you look at it, it is simple. 1 whole and 1 out of 6. Correct? So what do you get from here? That model makes it easy, right? So model helps. It makes things very simple, correct? So having a model is good for you. Sometimes you don't have such blocks. What you could do? You could make rectangles as we learned, correct? So let us say we have a number here, which is, let us say 8 out of 3. So that really means that we could make something. So 8 out of 3 means 3 means more than 2, right? So means more than 2. All right. So what we could do is we can make some rectangles. I'll make 3 for you. This is smaller than what I wanted to, but anyway. And we are going to divide this into 3 equal parts. Try to make as equal as you can. And then shade 8 of them. So we got 1, 2, 3, 4, 5, 6, 7, and 8. So that is 8 1/3, which I could write this as 1, 2, 3, 4, 5, 6, 7, 8 1/3 as 2 wholes and 2/3. Do you get an idea? So we could do by making such rectangles and dividing them into equal parts. So 3 means we have to divide into 1/3. And here is an alternate way. So I'll show you now how to do it without model, right? So we say alternate method. This is by division, right? We are dividing one block into equal parts. Now numerator is divided by denominator. So the idea is to divide the numerator, in our case it is 8, by the denominator 3. Now 3 times 2 is 6. The remainder is 2. Do you see? This is the remainder which you get. So this is this 2. The remainder part. You have still to divide this into 3 parts. That's what we're trying to say. And the 2 wholes, these 2 wholes are represented here as a quotient. So that is how you would actually convert from improper fraction to mixed numbers. Let's take up an exercise. So let's check this, 7 over 6. So 7 over 6, I could do it right there. I have to divide the number 7 by 6, right? So if I have to divide this number 7 by 6, we know that it could go one time and the remainder is 1. So you get one whole and one there. Correct? Now let me take a number where we have different numbers in remainder and quotient. Okay, so let's say 3 over, let me write here 10. Okay, so that means we have to divide, or rather 13 over 10. Okay, not 3 over 10, 13 over 10. So we have to divide the number 13 by the denominator 10. Now, you could divide it once and you get a remainder of 3. That means it could be written as 1 whole, remainder is 3, 10th. You get an idea. So that is how you could do it. Correct? So I hope the concept is clear. Now here is a practice question for you. Write the given improper fraction as mixed number. So let's write the fraction as 7 over 4, right? So this could be 1. And then the next question for you will be, you could try the number 6 out of, let's say, 5. Okay? So try these two as practice question. Now, let's do an exercise to compare the numbers when we'll give you numbers in the form of mixed numbers and the whole numbers. Okay, let's see. So we'll give you numbers in the form of improper fractions and mixed numbers. Now let's review what we have learned with the help of few examples. Example 1. Eggs are sold in cartons of 12. Describe 15 eggs as mixed numbers. Describe 16 eggs as improper fraction. You can actually copy the question, answer, and then look into my suggestions. So let's make a model to understand the situation. We are having in one carton 12 eggs. So let's say 1, 2, 3, 4, 5, 6, 7, 8. So what I'll do is I'll make 6 each. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have one carton with 12 eggs. And we have another carton in which we do not have 12, but we have only 3 more. So 12 we already have, and then we have 3 more. So what we have here, each carton has 12 eggs, but to describe 15 eggs, now we have 15 eggs here. You get my. So 12 plus 3. So that is how we get our 15 eggs. How can I describe this as a mixed number? That's the question for you, right? So I hope the concept is clear. Now do this part and then try the next question, which is, this time you have 16 eggs. That means one full carton, correct? And in the next one, you have how many? You have 12 here, since each carton has 12. To make it 16, you have 4. You have to write this as improper fraction. Does make sense? See how we can do it. Here you can see we have one full carton and we have only 3, but each was supposed to have 12, 3 out of 12. 3 out of 12. So that is how we get the answer for A. And for B, 16x, 12 plus 4, placed in 12s. So these are 12 over 12, and that is 4 out of 12, correct? So you add them up, 12 plus 4 is 16 out of 12. So you could just add these into the cartons, and each is 1/12, right? So since it is packed like this, does it make sense to you? So you can describe 16x as improper fraction. 16 is greater than 12. Does it make sense to you? So that is how we could do it. I'd like you to again read the question, understand, and then try it out, correct? And for you, let's say you have this time 18x. Write this as both mixed number and as improper fraction. So that is the question for you to do. Okay? So example 2. Compare using greater than, less than, and equal to. So we are given combination of mixed numbers and improper fractions. You need to figure out which is greater and which is smaller. How do we do it? Well, first you need to convert to improper fraction. That'll be easier. Then you can easily do it, right? So that is the hint for you. You can actually pause the video, answer, and then look into my suggestions. So let's look into 2 3 over 4. So when I write 2 3 over 4, it is equal to what? You multiply 2 by 4 and add 3. Denominator remains as 4. We get 2 times 4 is 8. 8 plus 3 is 11. It is equals to 11 over 4. So this part, as we just saw, is same as 11 over 4. So, and if you compare with 11 over 4, you get this as equal to 11 over 4. So the symbol here will be equal to. Does it make sense? Correct? So what we could write here is that 2 3 over 4 is equal to 11 over 4. Perfect. So that is how you have to do it. So take up the other two examples. Let me show you once again. So we get 1 times 5 plus 2 over 5. This is what I'm doing for 1 2 over 5. That could be written as 5 plus 2 is 7. 7 over 5. Now we are comparing 7 over 5 with 8 over 5. Which is greater? 8 over 5 is greater. Correct? So what do you get? You get greater than sign. I mean, this is less than 8 over 5. So you could say that 1 2 over 5 is less than 8 over 5. Does it make sense to you? So converting to improper fraction helps. The last one here. So we'll do again the same thing. We could write 1 out of 4 as equal to 1 times 4 plus 1 divided by 4, which is 4 plus 1, 5 over 4. Compare 5 over 4 with 9 over 8. Well, they have different denominators. I could multiply them both by 2 to get 10 over 8. Does it make sense to you? Correct? So once you get that, then you can say what is the relation between 10 over 8 and 9 over 8. Well, this is greater. So what we get here is greater than sign. So I hope that helps. Correct? So you could compare improper fractions with mixed numbers as shown here. The idea is always convert them to improper fractions to compare. Right? So I hope that's a good learning. Now to end this video, let's have a very interesting last example. We'll color and then conclude. I hope you enjoyed this journey of learning fractions greater than 1. So here we need to color a strip to represent the given fractions and the mixed numbers. The first one is 2 3 out of 4. Then you need to do 7 out of 2. And the last one is 2 1 out of 3. Right? You will also read this as 2 3 fourth, 7 halves, 2 wholes and 1/3. So there are different ways of reading also. So let's begin. The first one is 2, 3 out of 4. What will you do? We'll make rectangles. How many? More than 2. 1 more than 2, right? So we got 1, 2, and 3. Why did we make 3 rectangles? 2 wholes and a part. 2 wholes and a part, correct? Now these rectangles should be divided into equal parts to represent the fraction, especially 1/4. So those are 4 divisions. So let's divide them into 4 equal parts. So let's do them half and then half of half. So that becomes 4 equal parts. Clear? Now the last part is to color. You need to color 2 whole. That means you could color 2 completely. And 3 out of 4. So these are 4, just color 3 of them. So I hope the concept is clear, right? So that is how you do with the mixed numbers. Now let us see how can we do this when we are given improper fractions. 7 halves, right? So 1, 2, 3, 4, 5, 6, 7. Oh, so 7 halves means what? So we're looking into how many rectangles this time. So this will give me 2 halves, right? So if I divide, I get 1, 2. I need 7. So let me again divide into half. 3, 4. Halves. 5, 6. Oh, I need one more block. You could do counting like this also. 7. So we divided them and found that we need to make how many? 4 rectangles to get 7 halves, right? 7 halves. You could have converted this to mixed numbers. Dividing 7 by 2 is 3 and you get 3.5. That means 3 wholes and a half. Does it make sense to you? Now the last one, you have to make how many rectangles? Correct. You have to make 3 rectangles where 1 and 2 will be whole. The third one you could divide into 3 equal parts and select the first one. You get an idea. So that could be a faster way of doing it, correct? So you could just take 2 whole. You don't even have to show that division. 2 wholes. And the last one, just select 1. So that is another way of doing it. So I hope you understood the whole concept of how to represent fractions greater than 1. We could do it with mixed numbers or with improper fractions. We could represent them as shown here. We could use our blocks to show their combination also. Do you see that? So I hope you enjoyed this journey of learning fractions in a very different way. If you really like it, you can always subscribe to my videos. Your comments are highly appreciated. And if you subscribe to my videos, you can regularly get such beautiful videos. Thanks for watching and all the best.